When we talk about saving energy and climate, we usually look up at solar panels, wind turbines, skyscrapers. But what if the real opportunity is right beneath our feet? Our pavements, the network of roads, runways, sidewalks that connect our world, are every single day quietly shaping how much fuel we burn, how hot our cities can get, and even how much carbon we keep in the atmosphere. Regardless of the materials that we use, it is the pavement physical properties that matter the most. Because in the end, it's applying physics, not politics, that can help decarbonize our infrastructure. When we think about pavements and materials, we may think the environmental story ends when we lay the pavements. However, that couldn't be further from the truth. To explain why, allow me to introduce you the most widely used construction materials on Earth, concrete. Every property of a concrete road and pavements tells us an energy and climate story. Stiffness, how it resists deformation. Smoothness, how it interacts with the tires. Reflectance, how it deals with the sunlight. Carbon uptake, how it breathes and inhales in CO2. Conductivity, how it moves and even stores energy. Each property alone seems small, but together, the amount of benefits that we can gain far exceeds the amount of CO2 that we emit to the atmosphere because of the concrete production. So let's walk through how these invisible qualities can reshape the world above them. Let's start with stiffness. How much pavement bends when a vehicle passes over it. Pavements deform slightly under the load. That small deformation matters a lot. Every deflection creates a mini uphill for the tire, and climbing that hill costs fuel. It is the same reason that when we run on a soft, sandy beach, we feel more exhausted compared to walking the same distance on a sidewalk. Our research shows that pavement's impacts and its deflection shows an excess fuel consumption equivalent to 1% of the total transportation GHG emissions. Remember, the largest contributor to the US nation GHG emissions is transportation. When the deflection is less, we can cut fuel use and carbon emissions. Sometimes stiffness itself is sustainability. Then comes smoothness, the texture of the ride. If you have driven down a rough road, you have experienced all those bumps. So your vehicle, instead of moving forward, it goes up and down. It wastes fuel. That's because smoother surface reduces the rolling resistance, and for trucks, the smoothness can contribute up to 3% of the fuel consumption. Our vehicles consume energy to overcome air, friction, and surface drag, and pavement's roughness. Smoothness by just only 20% improvement can remove millions of roads and emissions from our cars and transportation systems. So smoothness is not just comfort, it is a climate action. And here's the striking part. On a highway in Missouri, when we think about the smoothness and stiffness of the roads, its overall impact is 3 times larger than the emissions that we have from producing those materials. So the way we design and maintain our road really helps us make a bigger influence on the climate change. Next, reflectance. How much sunlight a surface reflects instead of absorbing. Did you know that the dark pavement can trap the heat and makes our planet warmer? And our temperature, the local temperature, can increase by 1 to 3 degrees Celsius and even larger during the heat waves. That's a big deal for dense areas and cities. That's why we care about the urban heat island effects, where we see an increase in the cooling demand and therefore air conditioning systems. Lighter pavements, however, naturally absorb less heat, and this less absorption can achieve a big environmental benefits. If we just made the US pavements and road network more reflective by only 20%, then it is equivalent to removing the emissions from 3% of the vehicles from the roads. That's a big achievement that we can save passively every sunny day. But context matters here. In cold regions, definitely we have some consequences relevant to the heating demand. So we can see that we cannot take the next step as make everything bright white, right? But to design for the local climate zones. I want to tell you another secret about concrete. It inhales carbon dioxide. Over its life, a concrete pavement slowly reabsorbs CO2 from the atmosphere, a process called carbonation or carbon uptake. It's not fast, but it's very steady. When we look at the concrete pavements, the amount of CO2 that is sequestered in concrete pavements is equivalent to 6% of the emissions coming from the production of the cement that we use for that pavements. Half of this emission comes from and sequestration comes from the pavements in use, and the other half sequestration is relevant to the amount of CO2 that is absorbed in crushed concrete after its end of life. So we can get this number higher if we expose more concrete surface area to air. This can mean crushing it when the pavement is decommissioned. In a sense, every crack, every pore, and every recycled slab becomes a carbon sink. So yes, concrete can breathe, and sometimes exhaling less means designing it to inhale more. Finally, conductivity. How easily concrete transfers energy. In concrete, we often think of conductivity to distribute the heat uniformly. And this will help us a lot during the winter times, right? We need a lot of de-icing salts, we need plowing, and we see a lot of cracks. Concrete is generally susceptible to freeze and thaw. And inducing self-heating in concrete, we will remove all those issues. But there is a newer frontier here, electron conductivity, where we turn concrete to a giant battery in our backyard, where we can store electricity by adding a little bit of carbon black, which can come from clean hydrogen production, or recycling the tires. With the latest prototypes that we have developed at MIT, we can store enough electricity to light a US family building here for the night hours. Now imagine that this technology is applied to pavements. So once the electric vehicles driving on the road, they can get charged. Or we can use this during the night hours for street lights or even sensors. We often imagine the smarter infrastructure means adding sensors, AI, technologies. But maybe the true intelligence lies not in what we add, but more what we understand. If we can learn to work with the natural properties of materials, stiffness, smoothness, reflectance, carbon uptake, and conductivity, then even something as ordinary as concrete roads can turn into a climate-resilient solution. It's time to stop paving over nature's physics and start paving with them. Thank you.